Example 1, let f of x equal x squared minus 1 and evaluate each of the following. We have a numerical evaluation here going on, f of negative 5. So, going back up to our function definition, the function f is defined as the expression x squared minus 1. The variable of the function f is x, and x is going to be replaced by something, so you replace this x with the same something. But you do have to follow directions. So if it's a power expression, you have to put parentheses around your substitution. So if I were to write down this as negative 5 squared minus 1, that's not good, because only 5 is being squared, not the minus sign. We're replacing x with this entire value, so the entire value has to have whatever is happening to x. Okay, so typically what I do when I substitute is I put parentheses around my substitution until I see the parentheses aren't necessary anymore. All right? Then it's just an evaluation. Negative 5 squared is 25. 25 minus 1 is 24. The answer is 24. All right, so that's again numerical evaluation. We did that in Algebra 1. Again in Algebra 2, we've done those before. All right, just a quick reminder there, that's how you do it. Notice I didn't have to divide by negative 5 at the end. I don't have to, it's not like f times negative 5. This is functional notation. Change x to this number, evaluate. That's all you're supposed to do. Now, if the x gets changed to an algebraic expression, in this case 3b is algebraic, it has a b in it, we're going to do the same idea. We're going to go to function f, which is x squared minus 1. We're going to change x into 3b, 3b being 3 and b, two factors. I have to put 3b in parentheses to make sure both the 3 and the b are being raised to the second power, minus 1. So again, my expression is x squared minus 1. X is being replaced with a 3b. It's still being squared, and minus 1 is still there. 3 squared is 9, b squared is b squared, and that's it. That does factor if you're thinking, oh, that's 3b plus 1, 3b minus 1. That's great that you're thinking that way. The directions aren't to factor, they're to evaluate. Evaluate means to simplify completely. Go as far as you can, stop. So don't factor. If you want to mentally factor, just get some practice. It doesn't hurt anything, but give me the simplified answer. Okay, notice this part compared to this one. All right, has all the same pieces, right? It's got an F, has a 3, has a 3, has a B, has a B. This 3 is outside, that 3 is inside, and that does make a difference. Okay? So this is 3 being multiplied by the function f of b. So basically, there's an understood group here. And if I consider that that group is there, f of b means to go up to this function, change x into a b. That's going to be b squared minus 1. Notice I didn't need parentheses that time, so I just have a single object. All right? X is being changed to one letter b. B is being squared just like x is being squared. So b squared minus 1 is what f of b is. F of b is being multiplied by 3, so then I multiplied 3 times f of b. That's the distributive property since we've created a binomial here. 3b squared minus 3. That's as far as you can go. All right? Fourth one. F of a plus 3. A plus 3 is a binomial. X is being squared, so now my binomial is being squared. Minus 1. Again, the structure is always the same. It's always x squared minus 1. The new x squared minus 1. Notice a plus 3 squared is a binomial squared. We have our little shortcut for squaring a binomial. We square the first object. We double the product. And we square the second object. That's what that is, and there's still a minus 1. It's not been dealt with yet. 9 and 1 are like terms, so we should combine like terms when possible. So a squared plus 6a plus 8 is the best answer there. Notice that's a quadratic trinomial that's factorable to a plus 2 and a plus 4. Again, mental factoring doesn't hurt. Anytime you see something that could be factored, if you try factoring it, you're more likely to be able to notice it when it's possible. I can't look at an expression anymore without noticing factoring, as long as the numbers are small. When they start getting bigger, they're a little bit more challenging, but small number ones like that are pretty obvious to me. As soon as I look at them, I know that factors. It just pops in my head. Kind of like 2 plus 2 equals 4. It's kind of nice. The last one. Same objects, right? F of a, f of 3, there's a plus sign, all the same stuff. F of a is a function of f, and then f of 3 is also a function. F of 3 is kind of like this first one. f of a is kind of like this piece here, right? So if we look at these, f of a is going to be what?
A squared minus 1.
A squared minus 1. The plus sign is between these two things, so there's still a plus sign between these two things. And f of 3 would be what?
3 squared minus 1.
3 squared minus 1. In both cases, no parentheses necessary because a is just a single thing, 3 is just a single thing. You're just going to square a single thing, so that's all good. So altogether, out of all this stuff, I'm going to get a squared minus 1 plus 9 minus 1, which becomes a squared plus 7. And what you're supposed to notice is that f of a plus 3 is not equivalent to f of a plus f of 3. It's not like a distributed property type of thing. F of this and f of that, they're not equal to each other. So keep in mind that for the functional value section of the homework, that's how you do it. If it's algebraic, simplify as much as possible. If it's numerical, evaluate it to a single numeric value. I think the first 4 problems in your homework are like that. I think. There's only 6 tonight, so I think the first 4 are like that. The last 2 are like this next example. We're going to see.
There's only 6?
I think so.